Okay, here recording in progress. So share the screen. All right, so here we are. I've actually already finished 8.2. I'm going to start 9.1. So we are very likely to not have a very long day today, unless there are questions. Give you time to ask questions, but I was finished with 8.1. I was finished with 8.2. So I'm going to start 9.1. I will mention about the quiz tomorrow. The quiz is going to be involving finding the circumference of a circle I talked about before. So one of the nice things about calculus is a lot of the formulas that you first had in 5th grade, 6th grade, 7th grade, something like that, you can derive by techniques of calculus. So I've already discussed, for instance, the volume of a sphere, 4/3 pi r cubed, the surface area of a sphere, which we did just the other day, 4 pi r squared, okay, and a volume of a cone, 1/3 pi r squared h, and so on. Okay, for the quiz, we will discuss finding the circumference of a circle. Okay, and you should know the formula for the circumference of a circle, right? If not, you can look it up. And I'll just go ahead and tell you the quiz is very similar to 8.1 number 2, which we already did in class. So if you want to kind of get a heads up on the quiz tomorrow, go back to 8.1 number 2 and look up how we did that. If you need to look back up on the video, because the work is very similar. So page 548. Number 2, use the arc length formula to find the length of the curve y equals square root of 2 minus x squared, x between 0 and 1. Check your answer by noting that the curve is part of a circle. So a lot of the quiz mimics what happens here. In fact, I think what I'm going to give you is somewhat simpler than the way they have it over here. Okay, but in any event, you're going to help derive the formula for the circumference of a circle, which you should already know. Or if you forgot, you can easily look it up. Okay, so I'll give you the details tomorrow, but that's essentially what's happening for the quiz tomorrow, okay? All right, so start 9.1. Chapters on differential equations begins on 585. And we're just barely scratching the surface of differential equations. We're just doing 9.1, 9.2, and 9.3, just the baby steps of differential equations. Okay, as a lot of you know, there's an entire course called Differential Equations. In fact, that's usually the highest course that you can take at a community college, Differential Equations. Okay, we're just barely scratching the surface, the very baby stages of differential equations. But I know some of you need to take a course in differential equations, so we give you just a little bit of an introduction and say, what's this differential equation stuff all about? All right, so we'll just give you a little taste of it, a very small taste. So you're not going to know everything there is about differential equations just from these 3 sections. Okay, just a very little bit, just to kind of whet your appetite and say, what's this differential equation stuff all about? So again, we're just going to give you very baby stages of differential equations. You can take an entire course. In fact, many of you I know, you have to take an entire course called Differential Equations, and that's usually the highest course you can take at a community college. Okay, so these sections are in differential equations, and then the next exam covers all of this stuff. Okay, so 8.1, arc length, 8.2, area of a surface of revolution, and 9.1 and 9.3 is on differential equations, right? And we're aiming for what? Friday the 15th. And by the way, yeah, notice on our schedule, I even get started on some of chapter 10 beforehand because on paper, I would have finished everything here. I don't usually like to give a test on Monday. So if I finish everything here, I'm not going to give you the test on Monday. I'll just start doing more stuff and then wait until 10:15, I guess, for the exam. Okay. All right, so most likely we'll finish fairly early today. And then I'll let you ask questions. And if we don't have any questions, we're just done. And we're still a little bit ahead. Okay. So I'm starting 9.1, which wasn't going to start until tomorrow. Okay, so differential equations. What are differential equations? And let me just show you a little bit of the homework. So what do we have for the homework? 9.1. 1 to 7, all skip 6b and 7a. So just up to 7. So I just have to show you 1 through 7. It's on page 590. So here we go. And there we go. All right, so differential equations. First thing we need to say is, what is a differential equation, right? You need to just start off with just equation. So from algebra, you have an equation. Equation means there's an equal sign, and there's stuff on the left side and there's stuff on the right side. Okay, so that's an equation. That's an equation. That's an equation. That's an equation, right? So as soon as you have something equals something, that's an equation. So if I say 3x minus 5 equals 10, that's an equation. If I just say 3x minus 5, and that's it, that's not an equation, that's an expression, right? You don't have to write any of this down. It's stuff you should already know anyway. Okay, so first, the difference between an equation and an expression. An equation has an equal sign when you start. Okay, so equation, equation, and these are all equations. Equal, 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 right? Okay. But if I just put down, 47x, that's not an equation, that's just an expression. So these are equations. Okay. Well, differential, I think you can guess what it means. Something to do with derivatives, right? So a differential equation is simply an equation. So we already know equation, right? It's an equation that has derivatives, one or more derivatives. Okay, so I see a y prime, blah, 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 equals. That's a differential equation. Okay, this right here is not a differential equation. It's an equation. That's an equation, but it's not a differential equation. That looks like a differential equation. There's that dy dt Leibniz notation stuff. Okay, that looks like an equation, not a differential equation. That's a proposed solution. That's a differential equation. Okay, there's a y double prime, there's a y prime, and an equal, whatnot. Okay, differential equation, y double prime, and an equal sign. Okay, this is an equation. These are proposed solutions, but it's not a differential equation because there's no derivatives in there. Okay, that looks like a differential equation, y double prime plus y equals sine x. That looks like a differential equation. Okay, so simply stated, differential equation, just break down the 2 words. What is differential equation? I have to take a course, differential equation. Sounds scary. Okay, so equation, left-hand side, right-hand side. Differential, there's derivatives. Okay, so you have an equation, very easy equation. The first equations you had in algebra, right? Or like, I don't know, like I said, 4x equals 8, solve x equals 2, right? That's an equation. Differential equation now means there's derivatives. That's all. Okay, well, not that's all, as if that were easy. I mean, there's clearly more to it. Otherwise, how would you take an entire course for a whole semester on differential equations, right? All right, so again, you can take a whole course in differential equations. That's called Math 275. It's a 3-unit course. I know some of you have to take that for your major eventually. And we're just doing the very beginnings, the very baby stages of differential equations. All right, the first couple of problems involve what I call something, I would say, a show and tell. As we show that y equals blah, blah, blah is a solution of the differential equation y prime plus 2y or whatnot. Okay, show that this is a solution of the differential equation. Okay, show and tell. By analogy, suppose I just said show that x equals 3 is a solution to 2x minus 4 equals 2. Right? In your Algebra 1 class, we're not even talking about solving it yet. Just say, show that this works. You might say, where did you get that from? I don't know, just plug it in and it works. So I don't know how you did it. Now, of course, you are all experienced enough later on in your algebra, the very baby stages of algebra, right? Here's an equation. Show that x equals 3 is a solution. Okay, where did you get it? I don't know. Just try it. 2 times 3 minus 4 is 6 minus 4 is equal to 2. What do you know? It definitely works. Then, of course, later you learn techniques. You know, add 4 to both sides, divide 2. Oh, I got x equals 3. Right? That's the stage we are right now when I say show that x equals 3 is a solution to blah, blah, blah. Okay? And notice the language when we say is a solution, that means there might be other solutions. We don't know. Okay. Right now, you should realize x equals 3 is the only solution, right? We don't know that at the beginning. But say this is a solution, meaning there might be more than one solution. Okay, you are sophisticated enough to know that here there's only one solution, but I could make up something where there's more than one solution, right? So suppose I said show that x equals 5 is a solution to x squared minus 11x plus 30 equals 0. In my mind, I was just kind of going backwards with x minus 5, x minus 6 equals 0, right? So notice the language. At the beginning, you say, here's a solution. Before you knew anything about factoring, say, how did you get that? I don't know how you got it. Just plug it in. Plug in 5, plug in 5. 25 minus 55 plus 30. Yes, it's 0. It works. Now, of course, you know there is another solution, x equals 6. And it also works. Okay, so when we say blah, blah, blah is a solution, all we know is this works. There may be more solutions. We don't know if there's more, but all I know is this one works. Okay, so that's exactly where we are right now in differential equations. Here is a differential equation. Y prime plus 2y equals 2e to the x. Show that this solution works. So the first thing I notice is what does the answer look like? The answer looks like a function, or actually a class of functions later. Okay. Show this works. You might say, where did you get that from? I don't know. I don't care. I'm just going to plug it in and hopefully it works. And again, please notice the language. Show that this is a solution, meaning maybe there's the only solution. Maybe there's more. I don't know if there's more right now. All I know is they told me this works. So I plug it in and it works, right? That's just like the other one where I showed you where show that x equals 3 is a solution. This turns out to be the only solution. We know that now from algebra, right? Show that this is a solution. We know that there is at least one more solution, x equals 6, if I play the factoring game, right? Okay. But we're at the stage where, say, we don't know that. I don't know how to factor. I don't know how to add 4 to both sides and divide by 2, blah, 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 blah. Show that this works, right? The very baby stages, beginning stages of your algebra. So plug it in, it works. How did you get this? I don't know. Just plug it in. What do I know? It works. Plug in 5, it works. Where did you get it? I don't know. Just worry about it later. I know it works. So we're at that same stage here. Say, how did they come up with this? Don't worry about it now. Okay. Show that this is a solution of the differential equation. It's a function. Okay, I don't know where it comes from, but I'm going to plug in and hopefully it works. It's a solution, meaning at this stage, we don't know, is there any more solutions or if this is the only one, but I know for sure, dead sure, there's at least one solution and this is the one solution. Okay. So here we go. Y prime plus 2y equals 2e to the x. Here's the proposed solution. So I just work it out. What is y prime? So the derivative is 2/3 e to the x plus e to the negative 2x times negative 2 by the chain rule, right? And now I just do y prime plus 2y. By the way, when you're doing this, I don't put equals 2e to the x. Okay, independently, I just work this out. So you should not write equals 2e to the x. That's what I'm trying to prove. I'm trying to prove that it is equal to 2e to the x. I just put down y prime plus 2y. So here's my y prime plus 2 times the original function. 2 times 2/3 e to the x plus e to the negative 2x. And I work it out. 2/3 e to the x minus 2 e to the negative 2x. Then I distribute plus 2 times 2/3 is 4/3 e to the x plus 2 e to the negative 2x. That cancels that. And lo and behold, I now have 2/3 e to the x plus 4/3 e to the x, which is 6/3 or 2 e to the x. What do you know? It works. Okay. That's it. That's the end of the proof. Okay. This is actually not trivial. I do put the 2 marks. I'm not requiring you to put the 2 marks, but that actually has a special meaning in mathematics and logic. It means end of proof. Okay. Sometimes you see a little square for end of proof. Sometimes you see QED, which stands for which was to be proved. It's Latin, something like quod erat demonstrandum, something like that. You can look it up if you feel like it, but you don't have to. This is meant to say end of proof. Okay, I was supposed to prove that y prime plus 2y equals 2 e to the x. If this is the y, okay, I figured out the y prime, I added 2y, and what do I know? It does come out to be 2 e to the x, so that's the end of the proof. I have proven it. Okay, so logically or symbolically, end of proof, you can put the 2 lines like that. You might see me do that from time to time. Or sometimes you put a little square or QED. For me, you don't have to put it. I'm not emphasizing the logic that much. So if you want to put that or QED or put nothing, that's fine. You're not going to get any more points or fewer points because you put it. But, you know, if you want to go from a logician standpoint, right, and a logic standpoint, end of proof. All right. Two, same thing. Verify that blah, blah, blah is a solution of the initial value problem, t dy dt equals y plus t squared sine t, y of pi equals 0. Okay, the difference between number 1 and number 2 is they give me this initial value, y of pi equals 0. It means when you plug in pi, you should get 0. This is the easiest part of the problem, and yet ironically, I find students missing this because they forgot about it. Okay, so they would do all this stuff and get it correct, but forget about this. This just means when you plug in pi, you should get 0. That's going to be called an initial condition, and we'll need that a little bit later on. Okay. All right, so t dy dt equals y plus t squared sine of t. That's my proposed solution. So where did you get that from? Don't worry about it now. In fact, we're never going to know how to do this in our class. You have an entire semester of Math 275 differential equations that you can take, right? Where you'll learn techniques of how to solve this. Well, you know, just like in your Algebra 1, right? You eventually learn how to solve this, right? Show that x equals 3 is a solution. Plug it in. 2 times 3 is 6 minus 4 is 2. Right? And you say, yeah, how did you come up with that? Oh, add 4, divide 2, blah, blah, blah. Right? Same thing here. How did you get that? Factor, do the 0 factor property, and so on. Right? But at the beginning, it's a mystery, right? Plug in 5, it works. How did you get it? I don't know. Just plug it in. Okay. 5 squared is 25 minus 55 plus 30. It is 0. So it definitely works. I don't know how you got it, but it works. So we're at that stage, baby stage of differential equation. Okay. I don't know how they came up with this, but I'm just going to show that it works. Okay, so this is an initial condition, y of pi is 0. This is very easy. Just plug it in. So plug in pi, negative pi, cosine of pi, minus pi. Cosine of pi is -1. So I have negative pi times -1, which is pi, minus pi equals 0. End of proof for this guy. So this is done. That's the easy part. Initial condition. Okay, now for the hard part, this. So again, this is a differential equation. There's a derivative and there's an equal sign. Okay, so let's find dy dt. So what's the derivative of this thing? Looks like the product rule. First times the derivative of the second, negative t times negative sine t, plus the second function, cosine t, times the derivative of the first, which is -1. And then the derivative of negative t is -1. So clean that up. That's going to be what? T sine t minus cosine t minus 1. All right, so I'm going to do the left-hand side, LHS, left-hand side. The left-hand side was t times dy dt. So t times what I got over here. T times t sine t minus cosine t minus 1. So that's t squared sine t minus t cosine t minus t. So that's the left-hand side. Now, independently, I work out the right-hand side. Again, so I'm not setting them equal to each other. I'm proving that they're equal. So I work out the left side, and then independently, without making the assumption that they're equal, I work out the right-hand side, and then I take a look at what I got, and hopefully they're the same thing. So the right-hand side, RHS, was y plus t squared sine t. All right, so y, negative t cosine t minus t, plus t squared sine t. And then take a look at these two. What do I know? They're actually equal, right? Different order. T squared sine t, there it is, minus t cosine t minus t, which is the same as the right-hand side. End of proof. That's what the two slashes mean. Right? So I have satisfied. I showed that y of pi equals 0, meaning if you plug in pi, you get 0. And this differential equation is satisfied. I worked out t dy dt. That came out over here somewhere. I worked out y plus t squared sine t. And lo and behold, they're equal. End of proof. We're done. Okay, let me set you up with 3, and I was actually going to be finished after 3. Okay, and we're still in early somewhat, I think. Okay, so after I do 3, if anybody has any questions, you can ask them. Otherwise, we're going to adjourn. We're finished. Okay, this one's a little bit different. So I'll do 3. You can do 4 on your own. For what values of r does the function y equals e to the r x satisfy the differential equation 2y double prime plus y prime minus y equals 0? If r1 and r2 are the values of r that you found in part A, show that every member of the family of functions y equals blah, blah, blah is also a solution. Okay, what are they talking about here? So this is our first attempt to actually solve a differential equation to some extent. Y equals e to the rx. R is a constant. And they give me this differential equation that has a second derivative. 2y double prime plus y prime minus y is equal to 0. Okay, so how do I do that? Well, first, I guess I better figure out y prime and y double prime. So what's the derivative of e to the rx? It's e to the rx times the derivative of rx, which is r. What's the second derivative? Second derivative is the same thing. And again, by the chain root times another r. So it's r squared e to the rx. Okay. So first derivative, r e to the rx. Second derivative, r squared e to the rx. R is a constant. We have to figure out what it is. So now I plug in 2y double prime plus y prime minus y. So 2 times the second derivative. Get this in focus here. Okay, 2 times y double prime, there it is. 2 times r squared e to the rx. Plus y prime, there it is. Minus the original y, e to the rx equals 0. So I have this. Notice here, here, and here, there's a common factor of e to the rx. Factor out the e to the rx. 2r squared plus r minus 1 equals 0. That looks factorable. 2r minus 1, r plus 1 equals 0. I don't have to worry about e to the rx. That can never be 0. Exponentials can't be 0. So it looks like r is equal to 1/2 or -1, right? By the 0 factor property, 2r minus 1 equals 0, or r plus 1 equals 0, which leads me to r equaling 1/2 or -1. So that's the answer to part A. I guess I should have labeled part B here. So now what are they saying for part B? Yeah, I found my values of r, 1/2 and -1. So now what's the rest of the question saying? For those values of k, 1/2 and -1, where are we? sorry, those values of r, show that every member of the family of functions y equals e to the that plus b e to that is also a solution. Okay, we have infinitely many solutions, they're saying. So plug in 1/2 here and -1 here. So y equals a e to the half x plus b e to the negative x, where a and b are any real numbers, will also be a solution. Hence, we have infinitely many solutions, right? Pick any number that you want for a, 25, 80, pi, e, square root of 2 over 2, -1,000,000. Pick any real number you want for b. That whole family of functions will satisfy this differential equation. How do I prove it? Show and tell. Okay, so we have infinitely many solutions, infinitely many functions. Any function that looks like this will satisfy the differential equation, although right now we're not at liberty to say whether there still might not be more. Maybe there's more solutions, but definitely pick any number for A, any number for B, it'll work. How do I prove it? Show and tell. Okay, so y prime, what's y prime? A and B are constant, so the derivative of this is the same thing times a half, 1/2 a e to the half x. The derivative of this is the same thing times -1 by the chain rule, so -b e to negative x. Then y double prime, the derivative of this is the same thing times a half again, half of a half is a fourth. The derivative of this is the same thing times -1. All that does is change the negative b to a positive b. So here's my y double prime, here's my y prime. Plug into the differential equation, which is over here. Okay, so 2y double prime plus y prime minus y. Notice I don't put down equals 0. Okay. I have to prove that it's equal to 0. Okay, so I don't assume that it's equal to 0. I just work it out and hopefully I get 0. So 2y double prime. So 2 times that thing. There's y double prime. 1/4 a e to the half x plus b e to the negative x. Then plus y prime. Here's my y prime. And then minus the original y. Okay. And let's see. Minus y means subtract this. I just make them both negative. So minus a e to the half x minus b e to the negative x. Right. So everything here, maybe I should write this. Everything here is -y. It comes out to be 0. See if I can show that to you. This is half a e to the half x. Another half a e to the half x is 1 a e to the half x, but I'm subtracting a e to the half x, so that's gone. Similarly, this gives me 2b e to negative x minus b e to negative x minus another b e negative x. It's 0. It definitely works. Okay, no question about it. We have what we want. Okay. And that was all I was going to do today, folks. And I'm still a little bit ahead. Okay, so I've already done 1, 2, and 3 from the homework, so you can knock that off. I wasn't going to do 4. I'll let you try that on your own, but I will probably do 5 and maybe go on to 6 and 7 tomorrow. And tomorrow, of course, I'll give you the quiz. Again, the quiz, you'll be trying to derive the formula for the circumference of a circle, okay, as part of the quiz. So I'll give that to you tomorrow. But for today, I am pretty much done otherwise. So let me stop the share and check the chat. If nobody has a question, then we're finished. So let me check the chat. I don't see anything there. All right, so any questions, please, about anything? All right, then we're done. All right, have a good day, everybody. See you next time. Okay, bye, everybody.
Thank you.
Thank you.